In this video, we're going to take a look at the first part of lesson 3.5, which means we are going to I have to move this thing. I'm sorry, everybody. Graph, lines, and slope-intercept form. So let's just back up a second before we define slope-intercept form and look at graphing. And let's just go back to our table of values and the idea of what makes something linear. So if we look at our first table, to understand if it's a linear function or not, we want to look at the rate of change. And again, the rate of change we're looking at is the change in y over the change in x. And so in this one, from 4 to 8, we're adding 4, and 1 to 2, we're adding 1. 8 to 12, we add 4. 2 to 3, we add 1. 12 to 16, we add 4. 3 to 4, we add 1. And so our rate of change is 4 over 1, and it's a constant rate of change, which means it's linear. If we graph this in the plane, these points would form a pattern that could be connected to form a line. In example 2, in table 2, we're going up by 3 to go from 2 to 5, and up by 3 to go from 1 to 4, up by 1 to go from 5 to 6, and up by 3 to go from 4 to 7. Our last one is up by 4, and then again up by 3. So our rates of change are 3 over 3, which is equivalent to 1, 1 over 3, and 4 over 3. So this is not linear, has a variable rate of change. And the reason why I wanted to do this problem in our warm-up is because when we look at a linear equation and we look at that constant rate of change, that is what slope is. So slope is the rate of change between any 2 points in a linear equation and then there's a couple ways we define this. So sometimes we see delta y over delta x. Sometimes we write change in y over change in x. And then sometimes we describe this as rise over run. So again, when we're looking at 2 points, the change in our y value is our rise. It's how far we're going up or down, and the run is going from left or right. There's also a specific formula for slope, which is where we take the 2 y coordinates. We take 2 points on the line, We take 2 y coordinates and find their difference, and then take 2 x coordinates and find their difference. And that will tell us the slope. So when a line is written in slope-intercept form, it's of the form y equals mx plus b. The m and the b are going to be filled in with values, numbers, and the y and the x will stay variables. The m represents the slope, and the b represents the y-intercept. There are 4 types of slope. Slope can be positive, and when that happens, when we have a fraction that's positive, okay, we have to have a positive number on top and a positive number on the bottom, or it could be a negative number on top and a negative number on bottom. Either way, what happens when we move from one point to the other is that we're going up and to the right. Again, this is our rise, and this is our run. This line is, again, it's increasing because as the x's get bigger, the y's get bigger. So as our independent variable gets bigger, so like the more hours you work, the more money you make. That would have a positive slope. Okay? A line can have a negative slope where it is decreasing from left to right. And what is going to happen here is that we will get a negative fraction. That happens if we have a positive number divided by a negative or a negative divided by a positive. So when we look at our rise to run ratio and we're looking at one point to the next, usually I like to think of it as going down. So I'm decreasing on my rise, and I'm going to the right. So I'm increasing on my run. So my rise is negative, but my run is positive. That's because I always just like to move to the right when I'm graphing points, but you could actually think of your rise as positive, moving up, and then your run as negative, moving to the left. I personally find that a little more confusing, although the ratio is exactly the same, and you would connect the points in the same way. Now we still have our two special lines. Okay, horizontal lines have a slope of 0. So their slope is going to be 0. We're actually going to write a 0 there. And when that happens, okay, we are going to have any number as a rise. So our rise is going to be 0, and we can have a positive or a negative number as our run. Again, look at what's happening. Here's a point, here's a point. We're not moving up or down at all. We're just moving to the right. Vertical lines have what we call an undefined slope. And that's because when we have a vertical line, which by the way, is not a function, we are going to have a number, a positive or negative, over 0. And mathematically, when we divide by 0, that returns an undefined value. Like we don't have a value for that. So that would be undefined. And if we look here, again, what we're having is we're basically having only rise. We're only moving up and down, but no run. We're not moving left or right at all. And that's why our denominator, where our run is, no run, is on a vertical line. And on a horizontal line, we have no rise. When a line is in slope-intercept form, it actually makes it fairly easy to graph, okay? And it is in that y equals mx plus b. So if we look at this line, y equals 1/5 x plus 3, if we do y equals mx plus b, and we like line everybody up, our slope is 1/5, and our y-intercept is 3. So again, what does the slope mean? Okay, it means the y values increase, because it's a positive number, by 1 when the x values increase by 5. So the y values increase by 1 while the x values increase by 5. The y-intercept, remember we talked about this the other day, it's where the graph crosses the y-axis, and this is the point 0, 3. Anytime a graph crosses the y-axis, the x value is 0. So the good news is this gives us 1 point to start with, and usually this is our starting point. So I'm going to graph y equals 1/5 x plus 3 by starting at 3 on my y-axis. Then I'm going to use my slope. I'm going to start by going up 1 and right 5. So move up 1 and right 5, and there's another point on my line. Now I only need 2 points to graph a line, but sometimes people like to get 3. In this case, it looks like I'm running out of room on my plane, so I can actually reverse these and make both of the values in my slope negative. Remember, a negative divided by a negative is a positive, so it's still going to give me the same slope. And I can move down 1 and to the left 5, and there's my second point. We are going to draw a line through these points as if this were a continuous function. Okay, and again, remember, what is the graph of the line? It is a visual representation of the ordered pairs that are a solution to the equation. So if I pick this ordered pair here, this is the ordered pair 5, 4. If I substitute 5 in for x and 4 in for y, this should become true. And that's why it's a point on the line. All right, graph number 2. Y equals negative 2x minus 1, line number 2. Y equals mx plus b. Our slope is negative 2. Our y-intercept is negative 1. Let's start on the y-axis down at negative 1. Now looking at this slope, slope is a ratio, remember rise over run, and so I like to make it an actual ratio, make it into a fraction. I like to keep negatives in the numerator, and so this means I'm going to move down 2 units and right 1 unit. Down 2, right 1, down 2, right 1, and so forth. Again, everybody's making a line. That's a good news. If you want to go back and review again why this should make a line, it's because all variables are to the first power. Now, looking at this third graph, we actually do not have a y-intercept. This is y equals mx plus b. I do not see a plus b, and that means the y-intercept is 0 for the origin. If you notice, the negative is in front of the fraction. So again, I like to go ahead and put that in my numerator. I'm going to move down 3 and right 4. But just to make sure you understand, if I would have put the negative in my denominator, I would still end up with the same ratio, and I would move up 3, but I would move to the left 4. So moving up 3 and to the left 4 still gets me a point on that line. Let's try this way. Again, that down diagonal, it's just really hard to do on the PDF. All right, and our last one, I wanted to put this one here because it doesn't look like there's a coefficient in front of the x, but remember, it's a 1. So I don't see the coefficient, it's a 1. So my slope is 1. My y-intercept is 4. And again, 1 is equal to 1 over 1. So I'm going to move up 1, right 1, up 1, right 1, up 1, right 1. Now, I didn't graph any lines with that were horizontal and vertical because we did talk about those the other day. You should still know why the slope of a horizontal line is 0, why the slope of a vertical line is 0, or is undefined, excuse me. And you should be able to find the slope between any 2 points on a given line. Now, we will continue to work in later units about writing a line in slope-intercept form. So all you really need to do right now is to be able to find slope by taking the difference of the y values and the difference of the x values, writing them as a simplified ratio. And then if I give you a line that's in slope-intercept form, can you then graph it? As you're doing your graph, I, again, can't use a straight edge on the screen, but I encourage you to use a straight edge and to draw a line completely through the plane. All right, we will continue to talk about this in class. Great job.